Hey gang, today we're going to look at a third type of transformation. So far, we've dealt with translations, which slide a figure across the coordinate plane, and reflections, which flip an image or figure over either the x or y axis. So today, we're going to focus on 180-degree rotations. A rotation is a transformation involving the turning or spinning of a figure around a fixed point called the center of rotation or the origin. The center of rotation can also be called the origin. To rotate a figure 180 degrees, switch both of the signs of the original coordinate. So here we have our first example. We're going to go ahead and graph SIGN, which is sine. So sine starts at S being negative 3, 1. So we go left 3, up 1, label that S. Then I is negative 6, 1, left 6, up 1. G is negative 6, 4, so left 6, up 4. And N is negative 3, 4, so left 3, up 4. So we get this 3 by 3 square. And we're going to rotate it 180 degrees. So remember in the slide before, it told us that to do a 180-degree rotation, we simply change both the signs and the coordinates. And it's important for you to remember that. So S prime is going to become 3, negative 1. I prime is going to become 6, negative 1. G prime is going to become 6, negative 4. And N prime is going to become 3, negative 4. So now we can graph those coordinates and we will have a figure that's rotated half the way around the coordinate plane or over two of the quadrants and upside down. So S is going to be now positive 3, negative 1, bringing it here, S prime. I, positive 6, negative 1, bringing it here, I prime. G, positive 6, negative 4. And N prime is positive 3, negative 4. So here you see the shape being rotated around the origin. So each point is rotated around the origin to its new point. Now you don't have to draw these arrows. I'm just doing it to show you how it's rotated around the origin. Okay, so when we're doing this again, some people will be able to visualize it really easily. Others are going to need to remember the rule in order to complete the correct rotation. So again, rotating 180, remember to change both signs. All right, let's take a look at our next example. In number 2, again, we have O and E. So we're going to start with O at negative 3, 4. So left 3, up 4. N is at 2, 7. So that's right 2 and up 7. And E is at 4, 2. So that's right 4 and up 2. So we get this scalene triangle. It's called scalene because we have three sides of different lengths. And we're going to rotate it again 180. So we're going to change both the signs. So O prime is now going to be 3, negative 4. N prime is going to be negative 2, negative 7. And E prime is going to be negative 4, negative 2. So 3, negative 4 is right 3, down 4. Negative 2, negative 7 is left 2, down 7. And E prime is left 4, down 2. Creating a congruent triangle that's been rotated around the origin 180 degrees. So again, each of those points is rotated, and again, you don't have to draw these, around the origin half of a turn to get its new coordinate. All right, so I hope you understand that idea. When we're rotating 180, we're rotating half of a turn around the origin and changing both signs. You guys can try numbers 3 through 5 on your own. Okay, so we've seen a lot of algebra as well with doing some transformations, what's important is that you know that in a transformation, like a reflection, a translation, and a rotation, the size of the shape does not change. It's just moved into a different spot on the coordinate plane. So we have congruent shapes. And when we have congruent shapes, they are equal to each other. So we can use that idea to create an equation. So here, the length of a rectangle is labeled as 12 less than 3 times its width. So here we have our rectangle. The length is 12 less than 3 times its width. So its width is x and its length is 3x minus 12. And that's rotated 180 to get another rectangle. And again, the idea that it's rotated doesn't matter because we get the same size rectangle, so they're going to be equal to each other. And now it's labeled as 5 less than 5 halves its width. So this is x, and this is 5 halves x minus 5. So we want to find the dimensions of each rectangle using what we know about the rotations. So really, if these are exactly the same, we don't really need the x there. We could just compare the two lengths. So we could set 3x minus 12 equal to 5 halves x minus 5. We wouldn't include the x because that's not going to help us solve the equation. If we do x equals x, I can't solve it, but I can solve with the two lengths. So 5 halves, if we take that away from 3x, is like doing 2.5. 3 minus 2.5 is a half, so 1/2 x minus 12 equals negative 5. Then we add 12 to both sides. So we get half of x equals 7. And then we divide by a half or multiply by 2, and we get x equals 14. So here we could say the width is 14, and the width should also be 14 here. And if we plug it into both those equations, it should be the same. So if we do 3 times 14 minus 12, that's 42 minus 12, which is 30. And then if we do 5 halves of 14 minus 5, well, 14 divided by 2 is 7. 7 times 5 is 35, minus 5 is also 30. So in both cases, these rectangles are 14 by 30. And we've proved that they are exactly the same and have the same dimensions. All right, so you guys are now on your own to try today's exit ticket, and then you can move on to your homework.